Hey everyone, let's take a look at 5.8, number 24. We're going to evaluate the following indefinite integral, and we're going to use substitution to do that. And I just want to look at this, what we're integrating here, uh, 3 natural log of x plus 5 over x dx. Notice I can write that as it's basically this numerator divided by x, the same as this numerator times 1 over x, right? Or I can write 1 over x dx or dx over x. And when I look at that and I think about what I have in the parentheses here and what I have here, I just noticed that the the this function inside the parentheses here, its derivative, or at least a multiple of its derivative, is just 1 over x. So I'm going to let my u be this thing. You know, if you're going to let u be anything in here, letting u be x is never a good choice. So you don't want u to be x. That will not work. So I'm going to let u be 3 natural log of x plus 5, the whole thing up top. And look what happens when I do that. When u is 3 times the natural log of x plus 5, the derivative of 3 natural log of x is 3 times 1 over x. The derivative of 5 is 0. So simplifying, I just get 3 over x dx for du. And then I look over here, I've got 1 over x or dx over x, multiply both sides by 1/3 or divide by 3, and I get 1/3 du is 1 over x dx. And so notice what happens when I replace, this expression with u, this part becomes the u, and this part becomes 1/3 du. And so I just get u du, and that 1/3 can come out. What's the antiderivative of u? It's just u squared over 2, or 1/2 u squared by the power rule. 1/3 times a half is 1/6. There's my antiderivative in terms of u. Go back to the original variable, replace all of this with u, and there it is. Okay, there it is. Now, when I actually did this problem the first time, this is the way Achieve has the answer right here for this problem. Again, your numbers might be slightly different, but very similar. But I want to look at doing it just slightly different and see what happens. In this time, instead of choosing u to be 3 times natural log of x plus 5, I chose u to be natural log of x. And this will work as well. Let me show you. If you just choose u to be natural log of x, then of course the derivative is 1 over x. And we already saw how this expression is just this times dx over x. Well, if I replace this stuff with u, I get now 3 natural log of x is u plus 5. So I get 3u plus 5. And the dx over x, right, is the du. Okay, so if you did it this way, it's actually going to work because I can now find the antiderivative of 3u plus 5. The antiderivative of 3u is 3 halves u squared, right? Antiderivative of 5 is 5u. Don't forget your plus c. And then going back to the original variable, I replace u with natural log of x, and I get this expression here. Now, that's what I get if I do it with u equal to natural log of x. What we did to begin with, we chose u to be 3 natural log of x plus 5, and I got this thing here in the box. So compare the two. They do not look the same. Are they the same? Well, get rid of the plus c's for a minute. If you graph these two functions, or if you just compare these two functions, they are not equal for all values of x, but they differ by a constant, and therefore they are both antiderivatives. And I can show you that. If I start with this thing right here and expand out this part, what do I have? 1/6. So if I expand this out, 3 natural log of x plus 5 squared would be 3 natural log of x plus 5 times 3 natural log of x plus 5, right? And so pull it out. First times first. 3 times 3 is 9. Natural log of x times natural log of x is natural log of x squared. The outer is 5 times 3, 15 natural log of x. So is the inner, 15 natural log of x. So 15 plus 15, 30 natural log of x. And last times last, 5 times 5 is 25. Plus our c, right? Plus our c. So this 1/6 I can now multiply through. So 1/6 times 9 is 9/6, or 3 halves natural log of x squared. 1/6 times 30 is 5 times the natural log of x. And 1/6 times 25 is, well, 25/6. Okay. Now, this is what we started with. We get to here compared to what we had the last time. It almost looks the same, right? These two parts are the same. Okay, but then we have this 25/6 plus c. Well, what's 25/6? It's a constant. So 25/6 plus some constant is just another constant, right? In other words, like I said, this and the original and the one we got over here, right? These functions differ only by a constant. So they're both antiderivatives. Remember, that's why we have a family of functions when we find antiderivatives. So either answer is correct. Again, Achieve liked this one, at least that's what I saw. I would be fine with this answer. Either one is correct. So just get used to when you're doing these substitutions to try different things. Don't get stumped and just say, I don't know what to try. The only thing you should not try is let u be x. So you could let u be the natural log of x, or you can let u be 3 times natural log of x plus 5. Both of those methods work. Okay, hope this helps on this one.